Hello everyone. So today we're working on a Calc 2 problem. You're going to find the sum of the following geometric series if possible. So we've got 1 to infinity, 5 to the 2n plus 4 over 3 to the 3n minus 1, which I'll start off with. Then I'll move on to b and c. So a geometric series has a form by definitions that you see in many calculus books as follows: a plus ar plus ar to the n minus 1 plus da 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 equals series n equals 1 to infinity ar to the n minus 1. So basically it's a number a that you multiply by this number r, which we call the common ratio, to get to the next term in the sequence, and the series is just the sum of those. Now, if the absolute value of r is less than 1, the series that you see there converges to a over 1 minus r. And if it's greater than or equal to 1, the series diverges. Now, in what I'm going to say here is, where I wrote in general, just let me say a couple words up on what I mean by that. So what I mean is, if you have the two series where I have n equals m0 sigma ar to the n minus 1, that m sub 0 there, that's just any number here, or something of the likes that looks similar. So maybe you don't have your geometric series looking like r to the n minus 1, it's just r to the n. The idea is still the same. The convergence in itself is pretty much the same formula, except that the top term is no longer just a, it's a to the r to the m naught minus 1, whatever m naught is, that number, over 1 minus r. Or if you prefer, sometimes some people write a1 over 1 minus r. Okay, so that's the tools that we'll be using. Now for our first problem here, this technically is not in the form of the theorem that I wrote up there about the conditions for convergence divergence based on r. So I'm going to rewrite this expression. So we're going to use properties of exponents here. And yeah, so keep these in mind when you're doing these problems because they come up a lot. 5 to the 2n plus 4 can be rewritten as 5 to the 2n, 5 to the 4th, all over 3 to the 3n times 3 to the minus 1. That is by a property of exponents that says if you have a base raised to an exponent, it's equal to the base raised to each of those exponents multiplied. Okay, that's what I use there. The next thing I'm going to use is as follows. I see that I have a 5 to the 2n and a 3 to the 3n. They're both raised to the same variable n. So what I can do is use this property which says if you have a fraction where both the numerator and denominator are both raised to the same exponent, you can combine the fraction and raise it to the nth power. Okay, so that's what I use. And then I really don't care right now about these numbers. I'll get to that in a second. What I do care about is that 5 squared is 25 and 3 to the 3rd is 27. And yeah, 5 to the 4th is 625 and 3 to the minus 1 is just 1/3 because it's 1 over 3, but that's going to flip over, that's going to be 3. Okay, yeah, it's just another way to think. It's just that 3 to the negative 1 just goes back to the top here, and 5 to the 4th is 625 there. And does this series converge? Yes, it does, because the r, what you see there, now it's in the form that I can look at. R is 25, 27. So it's in the form of what I wrote earlier, or the theory where the conditions for convergence and divergence are outlined. So your r is 25 over 27, which is less than 1, so it's going to converge. And the sum converges to the first term, which would be, when you plug 1 in, which would be 625 times 3 times 25 over 27, all over 1 minus 25 over 27. So you get 625 over times 3 times 25 over 27 divided by 2/27. And what happens is all of this becomes 625 times 3 times 25 times 27 at the end. Okay, I'm sorry, not times 27, 625 times 3 And then the 27s would cancel, and then you would have a 2 on the bottom. Sorry about that. So that's what that would look like. And yeah, that is our final answer. 625 times 25 times 3. Let's do that out real quick. 625 times 25 times 3. So you get 46,875 all over 2. All right. Now, for the other two series, I'm not going to actually find the sum part. The sum is not too bad. What I really want to look at, though, is the r's here for each of these. And for this one, I'm going to rewrite it as a number raised to the n here. And that would be 9 to the n over 8 to the n times 2 to the minus 5, okay? I did that in the same manner, basically, that I had done the question right now. I'll just let you do the work there, which is basically like saying 9/8 to the n, and that 2 to the minus 5, that can come up as a 32. And yeah, 2 to the 5th is 32, so that's why that's the case. And the constants in itself don't matter. If you have any constants on the outside of the part that's being raised to the end, that doesn't matter in terms of the convergence divergence. It affects the sum, of course, but not the divergence or convergence. And my r in this case is 9/8, which is greater than 1, which will diverge. So this will diverge. And last but not least, this one here. This would be 25 times pi to the third over e to the fourth to the nth power. And I would have a e to the third on the outside here, 1 over e to the third. So pi cubed over e to the fourth. Well, let's see what that is. I'm not sure. So second pi to the third divided by second e to the fourth, and you get something that's less than 1. So yay, it's going to converge. And yeah, you would basically plug in the value when you plug 1 into your series, your first number. You would get 25 pi cubed over e to the 7th all over 1 minus pi cubed over e to the 4th here. Okay. And yeah, that would be your answer. Not nice. I'm not claiming it's going to be nice ever here, but that's what it would look like, okay? So that's pretty much how you take a geometric series and see if it converges or diverges. And yeah, well, let me focus on the fact that sometimes you have a series that doesn't look like what is written as like the definition of a geometric series, but that should not dissuade us from actually finding the convergence or divergence. It's a matter of just rewriting it pretty much as a number raised to the nth power and then going from there. Okay, well, thank you for your time, and I hope this helps.